Oh, hey there. I was just messing with the transparency effects on my command line because I kind of wanted to see the kitty cat while I was running my commands. Htop. Remember this? In the beginning of this course, in the first video or two, this might have looked completely crazy, like the Matrix, and you were just like, whoa, what is all this information? What's going on? But now that you're up to speed, this is the 11th video in the series, the 11th lesson. This should be looking quite familiar to you. If it doesn't, I would suggest you going back to the previous videos. So, now we know what processes are. Now we know which one is process 1, that's the initial process. We know what niceness is. We know what all the CPU and memory is. We know what the time is, the amount of time that it's spending using the CPU. We know what the priority is, the process ID number. We know about the user. We know that there's either parent or child processes. We know 4 different states that processes could be in. So that's pretty cool. And today we're going to be going a little bit further down the rabbit hole of processes, as there's a lot to know about processes. So let's keep going. There's a command df. If we go man df, df is a report file for system disk space usage. So it's pretty much like disk free, I guess is what you can... That's not what it's called, but disk free is one way to like remember that it's used to look for like disk space, free disk space. So if I do df-ah, and as you can see, A stands for all, and H stands for human readable. Alright, df-ah for all human readable. Here we have a whole bunch of stuff that we have mounted in our file system. Now these can be programs or processes. There is one I need to point out to you, this one. This is a proc file system. It's like a virtual special kind of file system. And by default, it's mounted on proc. And proc is where the Linux kernel posts information about current, running, or stopped, or sleeping, or zombie processes. So let's check out what is in proc. As we know, proc is right here. That's the full path for proc. So if we go ls/ for the root, we can see that proc is over here. Great, so if we do ls/proc, it gives us a whole bunch of stuff. And if we do ls all list human readable, then go to proc, it shows us a bunch of stuff. And if we pipe that into less, then it gives us a more manageable chunk to look at. And we can just hit enter to scroll through all of the procs that our kernel knows about. And on the right side over here, you will see all these little names here, and then you see a bunch of numbers too. Well, these numbers are all representing the process IDs. So here is one, so that's probably the initial process. And we have all sorts of different IDs for different processes. And then we even have some names for some processes that it represents. So this might be a driver process that was spawned by some kind of parent process that specializes in driver processes. And we can even filter through one of these processes. So let's say we want to check out process 10. Well, we can do ls alh proc 10, and then if we want one more, we can do pipe that into less, so that we can look at it more manageably. And here we get a lot more information about what that process 10 might be doing. You know, we have like, it's showing one about CPU set, CWD, FD, a whole bunch of stuff that I don't exactly know what this stuff is. But there is one thing that I could point out, where this row with all the zeros going down, this is the file size. So everything is 0 bits. That's kind of weird, right? And that's because these are created as they are read. They're updated on the fly. So if we want to see one of these, we can't just list it. We actually have to be a pseudo user to look at these. So let's hit Control Z to exit out of here. And let's go ahead and type in sudo. Let's clear it first. And now let's sign into root. So sudo-I to go into the interface of root, of super user. It'll ask you for your password. And now we are root. See, there's a difference. Up here, it's showing my name as Oxymonster in green. Now it's showing my name as root in white. And another different thing, we have a $sign up here. Here we have a pound sign. And now the pound sign means that we are acting as the root user, as the privileged user, as the super user, you know, the admin user. That's what this $sign means. $sign is just standard user. Pound sign is elevated user. Okay, so now we're here. We can go into the proc file system. Go ls. Here are all of our files. You know, here was the 10 that we were just looking at. There was one for the initial process, a whole bunch of other stuff. Let's check out the first process, which is process 1. Let's go cd1 and type in ls. So these are all of the processes or all the items that are inside the initial process. So let's start catting things just to see what these all look like. So let's do the first one, arch status. All right, it's not showing anything. Cat clear refs. Invalid argument. Okay. Cat com. Okay, that gave me something. Cat AUXV. Okay, that gave me some weird binary file that wasn't properly converted. Let's try another one. Cat CMD line. Okay, that looks kind of weird. It just added this weird thing to the beginning of my line. So let's see what current working directory this is in. Okay, showing it is a directory. It's showing that CWD is in this directory. And as you know, this is root. We can check out open file descriptors. We can look at memory mapping. We can concatenate maps. So this is all kind of raw information about processes straight from the kernel of Linux or of GNU Linux. So if we hit ls again, I would encourage you to just go through and concatenate each of these things just to kind of see what's in it. You don't really have to understand what you're looking at, but just start looking at it. And just a warning, some of these might not be in human readable format. It might be like binaries. So you will literally be looking at like a block of like weird, strange alien symbols and code that you just don't understand. And that's okay. So it'll be some fun. So there's a program called CMD, and that is the process that is currently executing. The CMD line is how the process was called from the command line of the process. CWD, if you list that out, it will show you the link to which the process is currently operating from. Then we have environ. This will show you the current environment variables. Then we have maps, which is kind of just like this crazy, and it's showing different processes and what share libraries they're using and what the memory mapping is mapped to and how the different processes are called upon by the kernel. Then we have some more. We got statm for memory. So basically, none of the files in here are meant to be read as human readable format. They're all kind of here to be parsed or run along with other programs. They're kind of main processes that make other processes work. And it's essentially a small puzzle piece to a big puzzle, but it's also a mandatory puzzle piece for that puzzle. So processes and functions that we've been running in these lessons, like htop or pwd, list, they all can communicate with all of these programs. So if we did something like cat maps less, well, another thing we could do here is do cat maps cut, and then we can define where we want to cut. So we could do like the little dash, then do field 1, and we could just pull back that information if that's what we want to look at. So you're starting to see how these commands are starting to put things together, right? A lot of the more complicated commands are just a bunch of simple commands put together. It's just like chained. You just chain a bunch of simple commands together to make one big complicated command. And really it's just a one-by-one, step-by-step kind of process. And thinking about that, it makes you start realizing how convenient programs like htop is, because htop ties into everything, and it on the back end it has so many different commands and processes and functions to make this run, but it's so easy to run it as a user. So you really have to you can really appreciate how much time htop is saving you, because now we don't have to go run around the file system and all the different directories chasing around where PID 222 is, or where PID 532 is, and what kind of memory it's running, and what the statistics are. You know, htop makes it makes our lives a lot easier. So another useful command that we can do is STrace. So STrace is a trace system that calls and signals. This is a tool that allows you to attach 2 or more different processes and really allows you to see what they're doing. You know, it can look at the signals that they're sending each other, or signals that they're sending and receiving by other processes or by the kernel. And you know, it's just like a debugging tool. It's great for troubleshooting and using diagnostics, and it's just a great overall tool to get comfortable with if you're a sysadmin or a site reliability engineer. And you can attach this and detach it from processes that are running, and it gives you an overview and even a deep view and understanding of what's going on with different processes that you wouldn't otherwise see that kind of information without STrace. Okay, well, that's the end of this lesson. It's just a very basic beginner kind of introduction on what the file system looks like in Linux. And in the next lesson, we're going to be delving deeper into the file system and exploring other programs and directories. Like, as you see here, we've got bin, boot, CD-ROM, dev, etc. We got home, live, all the different architectures. We have media, mount, opt, proc, which we just covered today. We have root, not to be confused with /root. We've got run, sbin, snap, a whole bunch of stuff. This is the entire universe of Linux, and we've just hit the surface. So stay tuned with me, guys. We're going to learn all the secrets of the world. Thanks for watching.